Hello everyone. I would like to make some video to try to understand the correlation and the coefficient of this correlation. And this is a way that I can improve my learning and try to help you if you have any trouble with this topic. So to understand this, we have to uh, get what is the main goal of this test. So the main goal of this test is that the test measure how the strongly two continuous variables move together and in what direction these two continuous variables move. The test asks whether the association we see is greater than what change will produce. For that reason, the null hypothesis is that the population coefficient is equals to zero. We don't have any correlation. The other part of the coefficient in correlation is called R, and it ranges to -1 to +1. And they say to us the direction, the magnitude, and the strength of this correlation. If you have zero, there is no linear link. This test has a companion that is R2. This or R squared, that is the proportion of the variables of the two continuous variables. So you can see the variables that they share. The other thing that you have to be aware of this is choose the correct statistical test. If your data is normal distributed, you have to choose the Pearson correlation. But if your data is not normal distributed, you have to choose the Spearman correlation, that is the non-parametric approach for correlation. So as I said, the coefficient R is start in -1 and go, that is the main of this is that this is a negative correlation and the +1 is a positive correlation. And how do you see in the scatter plot? This is easy to understand because if you have an R of -1, you have a strong negative correlation. You can go forward to moderate negative correlation. If you have zero, there is not correlation. If you have moderate positive correlation, is zero in between 0 and 1. And if you have 1, you have a strong positive correlation or close to 1. Why graphs matter in these linear regressions of when you are running a correlation? Because this is not only the correlation, it seems incredible in your paper, but this is the diagnosis about your data. You can see the clusters, you can see the direction, you can see the outliers. So this plot reveals how the data is correlate with both continuous variables. So there is an important thing that I have to tell you, that you can see an association, but this is not necessarily sufficient to cause, as we see in the next slide. Because remember that if you want to explore the causation, you have to follow the Bradford Hill viewpoints, that you have to see the biological plausibility, the consistency, the dose response of the treatment, the exposure, the intervention, well, whatever. And it's usually that you found the correlation in cross-sectional studies because you has a snapshot of that time. You don't follow the people. So how to assess the causation? The best way is through a randomized clinical trial. That is the gold standard. Or if you have an observational study, that is also a good approach to understand the causation of disease, how treatments goes. And for example, in the observational, you can adjust for the confoundings, make multivariable regression, matching, and propensity scores, as we see in the last class, in the last sessions. And And the most important for this is that require a temporality. The correlation is usually when you have a cross-sectional study that you don't have temporality, you have only one time in all the period of the study. What challenge and what do we have to do? R captures only linear, no, I think, or monolithic association in other parametric, no parametric test, but they don't assess the causation, only correlation. This coefficient is sensitive to the outliers and the range restriction. For that reason, you have to make some corrections, or in other cases, you can see, for example, the log transformations to try to avoid that. It's possible that when you have a large number of participants in your trial or in your study, it's possible that the R will be significant, but you have to be critical if that significance is important or has a clinical importance. And be aware about the ecological fallacy, that is, you can transpolate this study of that is too specific for in a specific region of the world to transpolate that characteristics to another specific part of or region of the world, because you have to make another study in the other region to be sure that you are found a real correlation or a real association. And always please report the confidence interval and the R square. You have to check the assumptions, the normality, and you can move to regression, and you can adjust for the covariables. So I think that is a good start to try to understand the correlation and the coefficient R. So I hope that this video helps to you to understand or has a better understanding about this topic.